In this section, we've discussed many aspects of mathematical modelling with respect to mechanics type situations. One question you might ask is, why do we model? The main reason for modelling is that real situations can be very complex. Imagine a situation such as serving a tennis ball. If you've ever seen slow motion of the ball moving through the air, you know that it doesn't remain as a sphere throughout its travel, it vibrates. The air that it's moving through is a compressible fluid. The resistance on the ball changes as the speed changes. And if you've seen something like Hawkeye at Wimbledon, you'll know that the speed, when the ball bounces, is quite a lot lower than when it's initially served. So the nature of the resistance on the ball will have changed even in that short distance. All of this is incredibly difficult to solve in its entirety, and that is why we model. Models are more easily handled. By viewing a tennis ball as a particle, we ignore all of the wobbling associated with it being a real object. We can ignore the nature of the air surrounding it by adding resistance in a way that we know that we can handle mathematically. And finally, models, even simple ones, can often provide good solutions. It's amazing how often a problem can be simplified quite substantially, and yet the solution provided by the model is quite close to what actually happens. If you can do this, then it's a good model. You also have to think about the situation you're in. If you need a very accurate answer or very accurate prediction, then your model will need to be more complex, a closer approximation to the real thing. However, if you don't need a really close approximation, you can work with a quite simple model.